Hello everyone, I will be showing you how to do linear regression in Julia. To start, we'll go over simple linear regression. Simple linear regression is where you plot two variables against each other, x and y, where x is explaining y. And we will get a best fit line for those data points. Our model for that will be y equals beta naught plus beta 1 x plus epsilon. Beta naught can be thought of as the intercept and beta 1 as the slope. Epsilon is the error term in the model associated with y. In Julia, we could use a couple of different functions to get estimates for beta naught and beta 1. If we are just using simple linear regression, we can use the function linreg and then our x variable and our y variable. If we want to use different models such as multiple linear regression or logistic regression, we will have to use the GLM function. So here's our code in Julia Pro, and in order to do linear regression we need to use the packages data frames, GLM, and stat plots. The dataset that we will be using is the MLB 2015 dataset. In order to look at variables in the 2015 dataset, we can use the names function. Next, what we're going to do is we're going to do a scatter plot between two variables. The variables that I chose were OBP, which is on base percentage, and runs. You can see here we have our OBP on the x-axis and we have our runs on the y-axis. So in order to do our simple linear regression and get our estimates for beta 0 and beta 1, we will just use the function linreg and then OBP, which is our x, and runs, which is our y. So here we can see that our beta 0, which is the first number that we are going to get, is negative 21.722, and then beta 1 is 286.01. Now if we interpret beta 1, what we're going to get is, for an increase in 1 point in on-base percentage, we are going to see an increase of 286 runs. This doesn't make sense because on-base percentage is a percentage, so if you add 1 to the on-base percentage, you're going to have an on-base percentage of over 100%. So what we're going to do next is we are going to times our on-base percentage by 1,000 to get a whole number to make so our regression makes more sense. And I'm going to do this for our SLG, which is slugging percentage. So next, what we're going to do is the simple linear regression. We're going to use the GLM function instead of the linreg function. So as you can see, we have the same estimates for our beta 0 and beta 1, which is negative 21.72, and after we times OBP by 1,000, it goes down to 0.286. Next, what we're going to do is add a couple more variables to our regression to make it multiple linear regression. So I will show you what those scatter plots look like. So here we have the three different variables: on base percentage, slugging percentage, and runs. So next what we're going to do is we're going to use the GLM function to get our estimates for beta 0, beta 1, and then also beta 2 and beta 3 now that we've added two more variables. So here our beta 0 goes to negative 25.37, beta 1 goes to 0.171, beta 2 goes to 0.073, and beta 3 goes to 0.135. Next what we're going to do is we're going to look at a categorical variable. The variable that I chose was the position, and we can see from this table what the positions are. So we have first base, second base, third base, catcher, center field, DH, left field, right field, shortstop. And this column shows how many times those positions are in the data set. So what we're going to do is we are going to initialize a variable called fast and make it an empty vector with 134 zeros. The reason why we're doing 134 is because we have 134 elements in our data set. And then after that we are going to do a for loop so that we run each element for fast, and we are going to use an if-else statement. So basically what this if-else statement is saying is if the position is second base or shortstop or center field, we're going to give it a value of 1. Otherwise, if it is not second base, shortstop, or center field, it's going to have a value of 0. And then if we look at our fast, we just get a bunch of zeros and ones, which is what we want. So in order to put this variable fast into our data set, all we have to do is create this MLB fast and set it equal to our variable fast. Then the last thing we're going to do is look at our estimates for beta 0 and beta 1 with our new beta 2 with our categorical variable. And as you can see here, we have beta 0 equals negative 24.66, beta 1 equals 0.292, and beta 2 is 2.34. So that is pretty much it for basic linear regression in Julia. Thank you for watching.